And so this is the solution to 2021 AA. This is AA, time zone 1, paper 1, but this video would be for section B. In case you missed section A, should be down there somewhere. You know how to find it. Again, we highly recommend you to try the questions before going through the solutions. But in case you have no way of finding the paper, you can take a screenshot right now. This is question 10 of section B, 11, and 12. That's it. Okay. Now, question 10 is a question that is shared with SL. It was the last question for SL, so in SL standard it's a bit difficult. Usually I would then say it means this is very easy for any HL student, but when I did it for SL, even I cannot get full mark. I lost like 3 marks in this because of a minor detail that IB seems to disagree with me. It's difficult to argue with IB, but I do think they didn't make this point clear in the syllabus. So when we get to there, I'll mention what that is. Alright, but the beginning of the question is super easy. You probably don't even need to read what's going on. You have a distribution, what's P, so all we know is the total probability have to be 1 for any distribution. So obviously P plus P plus P plus half P have to be 1. And that would mean 7 over 2P is 1. So P is 2 over 7. And then the expectation is just this time this, but this time this, blah, blah, blah. So 1 times P plus 2 times P plus 3 times P plus 4 times half P. So that's like 6, 8P. But P is 2 over 7. So 16 over 7. So again, it's shared with SL. Super easy. And then, well, actually, we should read the question. Turn out there are 2 die, and each of the die are biased. So the first distribution was for die A. It could roll 1 or 2 or 3 or 4 with those probability. We have another die B. Alright, and this is the distribution of Y, of the die B, alright? Now, here's where me and IB disagree. The question is, what's the possible range of value of R? Well, again, we know nothing about the distribution, so the only thing we can say is the total probability have to be 1. And also, a probability cannot be negative. Alright, so we pretty much know a probability has to be bigger than 0. Now, here's where you can argue, can a probability in the table actually be 0? In real life, you would say, okay, yeah, you can assign the probability of some event 0. But for me, I think if it's in a distribution, you shouldn't allow any entry to be 0, because if it can be 0, then the table doesn't have to end, right? You can have entries of 5, 6, 7, 8, so on and so forth, and just put 0 for all of those. Alright, that would make it a bit weird. Okay? That's my view. On the other hand, IB actually think it could be 0. So he think R will have to be bigger than or equal to 0. And then since the total probability have to be 1, but also adopting the idea that Q could also be 0, so the biggest possible value of R is 1. So IB think the possible values of R is between 0 to 1 inclusive. For me, when I did the solution for SL, I wrote without equal for both. That would make me get 0 mark for CI. And if I keep doing everything, at the end I would lose a total of 3 marks just because of that. So yeah, originally I usually don't check the solution before I do them, so I'll give you my honest reaction. But since the question was shared by HL and SL and they did the SL paper already, so I think I'll let you know about this point. But other than that, the idea is okay. Because next we want to find the possible value of Q. Well, then again, no probability can be less than 0 anyway, and I think it could be equal to 0. And then we know 3Q plus R has to be less than or equal to 1 because total probabilities, or actually if you add R as well, then it's equal to 1. But since R could potentially take a value of 0, so 3Q has to be less than or equal to 1, so Q is less than or equal to a third. Okay. Again, I didn't write equal in my solution, so I lose the mark. And they want the possible value for the expectation. So the expectation would be this time this, plus this time this, plus this time this, plus this time this. Q plus 2Q, 3Q, 4R. So that's like what, 6Q plus 4R. Alright, so the question is, like, what's the maximum and minimum of this? I hope you realize the minimum would not be 0, because it's not like both Q and R can be 0 at the same time, even though they both have a minimum of 0, right? Because of the fact that 3Q plus R have to be 1, so it's not like they can be both 0. Alright, so the best way of knowing the range would be you make one of the unknown go away. So we know 3Q plus R is 1, so R is 1 minus 3Q. So we substitute into here, 6Q plus 4, 1 minus 3Q, 4 minus 12, so it's 4 minus 6Q. Okay, now, so the smallest value of Q is 0, so if Q is 0, the expectation would be 4. Alright. So let me do this here. If Q is 0, the expected value is 4. But if Q is a third, then the expected value is 2, right? So that should give the upper bound, lower bound. Alright. Again, due to my view of not having equal, I also did not write equal for the expected value in my original solution, which would again make me lose a mark. Okay. So we have A and B playing games. Alright, A gonna roll die A. Again, that's like X, the first table. B roll die B, that's the second table. They tell you that the probability that A score less than B is half. Just from that, find the probability, find the expectation of Y. So now this is pretty much no trick. You do it by brute force. Alright, so you can say A roll a 1, so that's probability is P. Then B, right, in order for A to score less than B, B will have to roll a 2 or 3 or 4. So it's Q plus R. So it's 2Q plus R. And then you just keep doing that. So A could roll a 2. Again, the probability is P. Then B will have to roll either 3 or 4. And then A could roll a 3. The probability is also P. Then B will have to roll a 4. Alright, then if A roll a 4, B have no chance of rolling more than A, so we don't have to consider that. Question tell you this probability is half. Alright, you could put in P now. Remember, we know P from here, but it would be nice to factor it out. Then you'll have what? You have 3Q plus 3R. So P is 2/7. So that would mean 3Q plus 3R is like 7/4. Alright, obviously we need one more equation to solve this, but remember we also know this. 3q plus r is 1. So 3q, you can't see it. 3q plus r is 1. We subtract. So 3q minus 3q cancel out. 2r is like 3/4. So r is like 3/8. Alright, then q is what? 3q plus r is 1. So 3q is like 5/8. And q is 5/24. Alright, so you can see we can find q and r. Therefore, expectation would be easy to find. Remember the expectation was actually this. Alright, before we sub in r to get the range. So the expectation of y. Well, actually we can use this. They're the same, right? So 4 minus 6q. So that is 4, I believe. 16, 11/4. Okay. I kind of forgot the actual correct answer. Maybe I did some arithmetic wrong. So comment down below if you figure I did some mistake. It happens a lot. Next one, a vector question. Obviously, this is finally an Excel question. It's not in SL syllabus. Show that point is on L1. So they give you the line in Cartesian form. Obviously, it's very important that you know how to change forms. So you know how to change from something like a vector form. This is a vector form of a line into the Cartesian form of a line. Oh, that's actually the question. So you're probably more familiar with the vector form, which means maybe if you first convert it to vector form, then checking whether this point is on the line would be a bit easier to you, right? You just put it into R and then show that the same T would do the job for all three. In case you want to know how to check a point is on the line for a Cartesian form, you actually just sub it in one by one. Right, sub x into x, y into y, and z into z. And you want them to be the same. So -1 plus 1/2 is 0. So and then y is 0, and then 3 minus that is 3 minus 3. If you sub in, it's also 0. They are the same. Therefore, it is on the line. It is on the line on L1. So vector equation, you probably, I guess most of you have memorized the way, but if you want to know, what you do is you equate each of them to the constant, right? Most people use t or lambda. So let's say I use lambda here. So you make the first thing equal to lambda. Then the second thing would also equal to lambda because they equal each other, right? And the third thing would also equal to lambda. And then for each one, you make x, y, z the subject. So here, if you make x the subject, you get what? 2 lambda minus 1. So that's -1 plus 2 lambda for x. And then y is just lambda, so it's 0 plus 1 lambda. And z would be, what's that, 3 minus lambda? So z is 3 plus -1 lambda. And then you put it like a vector. Alright, obviously this is x, y, z, but we replace x, y, z by r, then that's the vector form. Find, well, we have another line. Find A such that the angle between them is 45 degrees. That's obviously cosine. You know, the dot product formula. 8 mark? Maybe there's some trick into it. So we do dot product. When you're looking for the angles between two lines, you dot the direction vector, because after all, only the direction vector have something to do with the direction. right? So this is the direction vector. So the formula is A dot B over the magnitude of A times the magnitude of B would equals to cosine the angle. Okay, I think this would be the first trick. Now the 45 is the obvious one, but if the two lines make an angle of 45, alright, then it is possible that the two direction vector, which go along the line or parallel to the line, would make an angle of 45, but it's also possible that the direction vector actually go like this way. Then the angle between the two direction vector would actually be this one. So for two lines to have an angle of 45, it is also possible for the angle between the direction vectors be 135. If you cosine them, you get what? 1 over root 2 and negative 1 over root 2. Alright. And then we actually dot that. That's like 2a plus 1 plus 1. Sorry for the not ideal handwriting. It's interesting that y and z components are the same. Is that a... did I do something wrong, or is that a trick? I don't think I did something wrong. Maybe it's a trick. Magnitude, you do Pythagoras, so it's 2 squares 4 plus 1 plus 1, a square plus 1 plus 1. Okay, maybe I can see it's not the easiest thing to solve. Again, this is a paper one, so we have no calculator. Do we want to square both sides? I'm thinking we want to square both sides. But once we squared, we lost the first trick because squaring a negative is still positive. That would ruin the question. Oh, I thought I caught the trick. Turn out, even if you forgot about it, it's still fine because you would just be squaring the thing. But I do think you have to square the thing. So let's square the thing. So we have 2a plus 2 squared over, when you square the square root are gone, so 6 times a squared plus 2 equals to 1 over 2. So here we can factor the 2 out, but remember when you factor out you have to square it, so it's 4, then it's a plus 1 squared, so a squared plus 2a plus 1 equals to 1 over 2, 6. Then we cancel out. We cross multiply, so 2 times 2 is 4, a squared plus 8x plus 4 equals to 3a squared plus 6, so a squared plus 8a minus 2. Hey, we can't factorize that. Did I do something wrong? Probably not. I guess we'll have to use the formula. So it's negative 8 plus minus square root b squared minus 4ac for 2a 72. Or 2, should we simplify that? That's like 6 root 2 over 2. So minus 4 plus minus 3 root 2. That seems to be the possible values of a. Yeah, we assume I get it right, I guess. The next is they want L1 and L2 to have a unique point of intersection as long as A is not K. First, find K. Well, I guess they intersect as long as they're not parallel. Well, actually, that's not true. They could be skew. Oh, maybe that's the trick. The trick is that this is 1 minus 1, this is also 1 minus 1. So they can't be skew. Alright, so as long as they're not parallel, they'll have to intersect because of that. And for it to be parallel is obvious. If A is 2, then they will be parallel because they have the same direction vector. So K should be 2. As long as K is not 2, sorry, A is not 2, we have to find the coordinate of point A, the intersection. Pretty much have no choice but to brute force solve for the intersection, I think. So the line is minus 1, 0, 3 plus lambda 2, 1 minus 1 equal. So we equate them, right, to solve for intersection T, A1 minus 1. A1 minus 1. So we do the normal thing for solving intersection of a line. It's just we have an extra unknown, which is A. So I guess the intersection would be in terms of A. We have no choice, right? Yeah, in terms of A. So here you can see clearly the trick about they're both 1 and minus 1 that I mentioned. You can see that if you add up the second and the third, you simply get 3 equals to 3, which is always true. Alright, that's pretty much why these two lines can't be skew. It's either parallel or they intersect. Alright, but we do have to find either lambda or t. So we'll probably use the first two equations to do so. We multiply the second equation by 2. 2 plus 2t. And then we subtract. So minus 1 with a negative 2 plus a minus 2t. So t is 1 over a minus 2. Right, because we add the negative 2 to the left and then divide a minus 2. Then now we know they intersect, so we don't actually need lambda. So we'll just put t into the second equation. So it's 0, 1, 2 plus 1 over a minus 2, a 1 minus 1. So x would be 0 plus a over a minus 2. Y would be 1 plus 1 over a minus 2. Z would be 2 minus 1 over a minus 2. That should be the point of intersection. 7 marks and 8 marks. I don't see why they're worth that much, to be honest with you. Yeah. Again, actually, is just getting easier and easier. I mean, I keep saying that last year, if you haven't, well, if you're interested, you can check out my solution of last year's paper and also the specimen of your new syllabus. I guess I should not repeat myself that much. Last question. Last question. Function second derivative. So this is 1 plus x to the power of half. So the first derivative is chain rule. So this would be easy for everyone. I mean, chain rule again. Negative 3 over 2. So this is basically what they have there. I mean, you can pretty much just copy what they have there at this point. I don't think they care. Wow, but 3 mark. That's 3 mark. Man. Mathematical induction. I really do think this paper is... I mean, is it too easy? The last question. Okay, part C as a Mac Korean. is, I guess, it's not the easiest, but it's certainly not difficult. The mathematical induction is basically never difficult. Um, the vector question is kind of tricky because it's a tiny bit unusual. This, as I said, I lost 3 marks. The counter question is fairly simple. L'Hopital is really simple. And then 7 is time consuming at best, right? Even though if you didn't figure out the fastest way. 6 is almost like a standard level kind of question, other than the fact that the identity wasn't given. And then the rest are just SL questions, right? I mean, you tell me, right, down below in the comments section. Do you find this paper hard? I mean, it is possible, though, that paper 1 is easier because paper 2 gonna be harder. That is possible for IB to make one of the paper hard. So I guess we'll see. So we'll do the induction, right? So it don't have a huge amount of space, but maybe I should do it here. I don't want it to be too messy, because for induction, it is the formatting that's most important. So the left-hand side of what you want to prove is this. So it's f1x. So that's really the first derivative, which was this. So it's half 1 plus x to the power of negative half. Right-hand side of the formula is negative a fourth, 1 minus 1, 2 times 1 minus 3 factorial over 1 minus 2 factorial. Wait, there's a negative? Oh, and start from 2. So the base case is 2. Yeah, I almost lose a mark there. So this 2 is for the second derivative. That's why part A asks you to get the second derivative directly. Yeah, it makes sense. So negative 1 over 4 square root 1 plus x to the power 3. So n is actually 2. So this is 2, this is 2, this is 2. 2 minus 2 is 0. 0 factorial is defined to be 1. So 0 factorial is actually possible. Negative factorial, not so much. So this is a 4, negative a fourth to the power of 1. We have 4 minus 3 factorial, that's 1 factorial, so 1. 0 factorial again is 1. 1 plus x, negative 3 over 2. And that's exactly what we had. Okay, therefore the statement is true for n equal to 1. True for n equal to, oh, not 1, sorry, 2. Then assume for some n equal to k bigger than or equal to 2 that the statement is true. That is if you take the kth derivative, it will be what the formula says. K minus 1, 2k minus 3 factorial, k minus 2 factorial, 1 plus x, half minus k. So for n equal to k plus 1, we want to find the k plus 1 derivative, which is of course the derivative of the kth derivative, and by assumption the kth derivative is this. So again, mathematical induction is almost never difficult, except maybe the inequality ones that happens a few years ago. I think I make you drop the power. I think I make a video on that already. Take 1 away, so it's minus half minus k. Well, actually, I should just write -1. That seems nicer, because I do want the k to becomes k plus 1. Okay, now I do need the power of k to increase by 1, which means I need the power of -4 to increase by 1. And I need a bunch of these factorial stuff. But it seems that I don't have a lot to work with. All I get is this. Oh. Is this harder than I thought? Don't have a lot. So these I will just copy for now. For this though, I probably get a common denominator. So it's 2. So it's 1 minus 2k, 1 minus 2k. What are those factorial doing there? That's a bit confusing. So here we have we take out the minus k plus 1. Alright. So this part is easy. We already have the k plus 1 that we want. So we can go to the side and kind of think what we need. If the k have to increase by 1, we should have 2k plus 1 minus 3 factorial, and k plus 1, and then minus 2 factorial. So we are looking for 2k, expand 2k plus 2 minus 3, so 2k minus 1 factorial over k minus 1 factorial, which is, of course, 2k minus 1 times 2k minus 2 times 2k minus 3 factorial, and k minus 1 times k minus 2 factorial. Okay, so it seems like we need these 3 extra factors. Alright, because we already have these. And the 2k minus 1 is already there. It's here. Except the negative, but we do need a negative because we need an extra negative here. We need an extra negative a fourth. And then this is 2k minus 2, so if we take the 2 out, it will actually cancel out with the k minus 1. So that should make it obvious what to do. So we still copy the front. But here, first, instead of 1 minus 2k, we turn it into 2k minus 1 by bringing out a negative. Then we multiply both the top and the bottom by a k minus 1. Alright, and we need an extra 2 on top, so we times this by 2. But then if we multiply the top by 2, you multiply the bottom by 2 as well. So you multiply this 2 by 2, so 4. The rest we can keep. So that should do it. Right, this is the negative a fourth to go to the front. This times this is obviously k minus 1 factorial. These multiply. It's a tiny bit less obvious. But it should be okay, I mean. And keep the rest, plus 1, bracket. So that's what we want. Okay, therefore you write the paragraph. The statement is true for n equal to k plus 1 if it is also true for n equal to k. Therefore, by the principle of mathematical induction, therefore by the principle of mathematical induction, usually what I do is I copy the question. The nth derivative of fx is what the formula said it was. What was it? There. N minus 1 2 what? 2n minus 3. So you're basically copying the question. for n it was bigger than or equal to 2, right? N being integers, obviously. Okay, MI, it's never difficult. Next we have a G, and H is the product of F and G. We want the x squared term of its Maclaurin series. Alright, obviously that would mean we have to find h0, h prime 0, and h prime prime 0. Well, actually mostly they only care about h prime prime 0 because they only care about the x squared term. So we'll have to find that. Okay, so hx is f times g. So if we differentiate that once using product rule, I mean obviously doesn't matter if you differentiate the first thing first or the second thing first. I usually differentiate the first. Since it's a plus, doesn't matter for product rule. Then we need to differentiate that again. Then we need to product rule both of them twice. I mean, like product rule them both, so I have to do it twice. So differentiate the first thing, copy the second, plus copy the first, differentiate the second, plus for this, differentiate the first, copy the second, plus keep the first, differentiate the second. Okay, yep, that should be right. So this is f prime prime x gx plus. So you can see doing repeated product rule is almost like doing an expansion. And that is actually a thing. It's called the Leibniz Theorem. Yeah, someone have done that already. So you plug in 0, f prime prime 0, g0, x, oh 0, there's a 0. 0, g prime 0 plus f0, g prime prime 0. F prime prime 0 is what? We have f prime prime x here. If we plug in x to 0, we get negative a fourth. Negative a fourth. G0 is here. If x is 0, you get 1. 1 plus 2. F prime 0, we plug 0 into the first derivative. Half. G prime 0. G prime is obviously m, e, and x. So if x is 0, you got m plus f0. What's f0? Here, root 1 is 1. G prime prime 0, g prime prime x is m square e mx, so it's m square if x is 0. So it's negative a fourth plus m square. Okay, so the x squared term of the Maclaurin series would be h prime prime 0 over 2 factorial times x squared. Just coefficient, so ignore the x. So negative a fourth plus m square over 2 should be what they want, 7 over 4. So what, times 2, 7 over 2 plus a fourth. That's like 15 over 4, I think. So we have 4m squared plus 4m minus 15 equal to 0. Can I factorize this? I feel like I can. 2m plus 3, actually minus 3, plus 5. Yeah, that works. Minus 3 equal to 0, so m is 3 over 2 or negative 5 over 2. Yeah, hopefully That's right. I wouldn't say the whole paper are like straightforward, but certainly not difficult. Alright, this will be it for paper 1. I'll see you guys in paper 2.